Hello my dear students, welcome back to your channel. Hope you all are doing well. Today with this video, I will try to cover all important points and formulas of chapter 13 nuclear. In this chapter, different topics to be covered are first, composition and size of nucleus, then mass energy relation, then mass defect, and at last nuclear fusion reaction. This chapter is very small, only 3 or 4 topics are there, right? So let us start first. What do you mean by chapter name, that is nucleus, right? You know, entire positive charge, you can say entire mass of the atom is concentrated in a very small space, that is called nucleus of an atom. So nucleus consists of protons and neutrons, and these protons and neutrons are collectively known as nucleons. So inside the nucleus, what is present? Protons and neutrons. Now different terms related to nucleus. First one is atomic number. What is this atomic number? It is represented by capital Z. It is number of protons in the nucleus of an atom of the element. What is the number of protons present in the nucleus of any particular atom of an element? That is called atomic number. So you can say atomic number is equal to number of protons, right? Now next, mass number. Mass number is total number of protons and neutrons present inside the nucleus of an atom. Total number of protons and neutrons, and total number of protons is what? Atomic number, Z plus N. So this Z plus N is called mass number, represented by A. So A equal to Z plus N, and from this formula you can easily find number of neutrons in an atom, that is N equal to A minus Z, right? After this, nuclear mass. Nuclear mass is total mass of protons and neutrons present in the nucleus of an atom. This is called nuclear mass, or you can say atomic mass. Total number of protons and neutrons mass means what is the total mass of nucleons. This total mass of nucleons, or you can say total mass of protons and neutrons, are called nuclear mass, or you can say atomic mass also, right? Now next is general representation of the element. It is represented at X, Z, A, or you can write X below base Z and above A. What is this? X is symbol of any element, Z is atomic number, A is atomic mass or mass number. So if suppose for example oxygen had atomic number what? 8 and mass number, atomic mass 16. So you present O816. In this way, if X is any element, you can represent it as XZA. For example, hydrogen you can write H11, where 1 is atomic number and mass number is 1. Oxygen 16, 8, where 8 is atomic number and 8 is mass number, because it has 8 number of protons and neutrons. Now after this, next very important topic is measurement of atomic mass unit, because mass of atom is very small, or nucleus is very small, so you can't measure in kilogram. Kg is very larger unit, right? So the unit which is used to measure atomic mass is called atomic mass unit. And what is this atomic mass unit? It is defined as 1/12 of mass of carbon-12 nucleus. It is denoted by AMU, or you can write U, atomic mass unit. And in a 1 atomic mass unit, how much kg is there? So how you find? 1 atomic mass is 1/12 mass of carbon-12 atom. When you put the value of mass of 1 carbon-12 atom, you get 1 AMU equal to 1.67 into 10 to the power minus 27 kg in terms of electron volt, because mass can be converted in energy. So it is equal to 931 mega electron volt. It's very easy and very important formula. 1 AMU equal to 1.67 into 10 to the power minus 27 kg. It means mass of atoms or nucleus is very small. It is 10 to minus 27 kg. So you can easily find that its mass is very small. And this 1 AMU is equal to terms of electron volt 931 mega electron volt. And it is measured by instrument known as mass spectrometer, right? Hope it's clear to all of you. After this, there are different types of atoms or nuclei. Based on how many number of atomic number, mass number, There are different types of atoms. First one is isotopes. What is isotopes? The atoms of an element having same atomic number but different mass number. Those elements having same atomic number is same. It means same element but mass number is different. For example, H11, H12, H13. In all these three, atomic number is 111 but mass number is 1, 2, 3. So these are isotopes of hydrogen having same atomic number but different mass number. Next, isobar. The atoms of elements having same mass number but different atomic number. And if atomic number is different, it means element is also different. You know, one element, only one atomic number is there, but mass number is same. For example, H13 and He23. Here atomic number for hydrogen is 1, helium 2, but mass number both has 3. Mass number is same. In the same way, Na1123 and Ne1023 both have mass number 23 but atomic number 11 and 10, and these are isobars of this, right? Next one is isotopes. What is this isotopes? The atoms of different elements having different atomic number and also different mass number but having same number of neutrons. Here both atomic number and mass number are different. For example, H13, He24, C6H14, oxygen 816. In all this one, first one H13 and He24. These have different atomic number and mass number also, but number of neutrons is same. Number of neutrons is what? Mass number minus atomic number, Z, 3 minus 1. Here number of neutrons is 2, and in this one also 4 minus 2, 2. So both have same atomic number, so these are isotopes. In the same way, C614 and oxygen 816. Here also number of neutrons is 14 minus 6, 8, and here also number of neutrons are 16 minus 8, 8. So these are isobars. Now last types of atom is isomers. Atoms having the same mass number and same atomic number, both are same but different radioactive properties are called isobars. So these are our different types of nuclei. Then after that, size of nucleus. It is very, very important. It generally comes in 2 or 3 marks questions, right? So how you find size of nucleus? Okay, you know, experimental observation shows that volume of a nucleus is directly proportional to mass number. Greater the mass number, greater is the volume. So you can write V is directly proportional to A. So you know volume of a sphere is what? 4/3 pi r cube. R is radius of the sphere. Okay, na? So this 4/3 pi r cube is directly proportional to A. Then from here r cube is directly proportional to A. Or you can write R is directly proportional to A to the power 1/3. So after this you can write, you remove the proportionality constant. You get R equal to R naught A to the power 1/3. R naught is called nuclear unit radius and its value is given by 1.2 into 10 to the power minus 15 meter, and A is mass number. So this is relation between radius and mass number, because greater the mass number, greater is the radius of, or you can say size of nucleus. R equal to R naught A to the power 1/3. It means size of nucleus depends on mass number. It is rated by this formula, R equal to R naught A to the power 1/3, and R naught is 1.2 into 10 minus 15 meter. Now after this topic is also important, density of nucleus. You must remember one point, that it is independent of mass number. You can prove it also. Density of nucleus is what? Density is what? Nuclear mass by nuclear volume. Nuclear mass is total number of mass of the nucleus. You can write M into A, and volume of nucleus is 4/3 pi r cube. Right now, you put the value of R here. R is R naught A to the power 1/3 cube. After solving this one, you get density equal to 3m by 4 pi R naught cube, and its value becomes this one. It means it is constant. Density of nucleus is constant. It is independent on mass number. This point is very, very important. It does not depends on mass number, right? Density of nucleus. Nuclear density is independent of mass number. Therefore, it is same for all nuclei, right? Hope it's clear to all of you. After this, next important topic is Einstein's mass-energy equivalence relation. According to Einstein, mass is also a form of energy. Einstein gave mass energy equivalent relation as E equal to mc square. It means any object which has got some mass m has energy associated with it, and it is given as mc square. If any object having mass, it has some energy which is given by E equal to mc square, right? After this, nuclear binding energy. Actually, it's not in your syllabus, but still you must know what do you mean by nuclear binding energy. What is this nuclear binding energy? It is energy required to hold an atom's protons and neutrons together in a nucleus. You know, inside the nucleus, neutrons and protons are present and both are repulsive in nature. So how it binds inside the nucleus of an atom? This is nuclear binding energy. How strongly it binds inside the nucleus, right? They are bound to each other inside the nucleus. So nuclear binding energy is energy required to hold an atom's inside protons and neutrons together in the nucleus. Or you can say it is energy needed to separate nucleons. It means protons and neutrons from each other. And it is given by binding energy is equal to ZMP plus A minus ZMN minus MC square. ZMP is what? MP is mass of proton and Z is total number of protons. So total number of mass, total mass of proton plus total mass of A minus Z means neutron. Mn is mass of 1 neutron. So total mass of neutron inside the nucleus, total mass of proton and total mass of neutron. It is mass of nucleus minus this is mass of nucleus when it is at rest. So into C square. This is the formula for binding energy, ZMP plus A minus Zm minus M to the then multiplied by C square. Hope it's clear to all of you. And after this, next very important topic is mass defect. It's very important. What do you mean by mass defect? Mass defect is difference in rest mass of nucleus and its constituent nucleons. It means protons and neutrons. When the nucleus is at rest, its mass is always less than mass of its constituents, means nucleons. When nucleus is at rest, suppose its mass is m, and it is always less than its mass of constituents. It means mass of protons and neutrons, and this difference is known as mass defect, also known as excess mass. It is noted by delta m. So delta m is given by total mass of proton plus total mass of neutron, and this total mass of proton and neutron, it means mass of nucleons is always greater than rest mass of nucleus, that is, so it minus m. This difference in mass is called mass defect. For example, oxygen 816. You know, oxygen has 8 protons and 8 neutrons. You know, mass of 1 proton and 1 neutron. So you can easily calculate mass of 8 protons, 8 into this one, mass of 8 neutrons, 8 into 1.00727 U. Therefore, oxygen nucleus has total mass how much? 8 proton plus 8 neutron. Total mass is 16.12744 unit. But from a spectroscopy, rest mass of nucleus is given as 15.9949. So there is difference between this mass of nucleus and rest mass of nucleus, and this difference is called mass defect. And this difference in mass appears as energy, because mass is also a form of energy. Any object having mass, it must have some energy associated with it, right? After that, what is relation between this mass defect and nuclear binding energy? Nuclear binding energy, it is noted by EB, and you know nuclear binding energy is amount of energy required to hold the protons and neutrons together inside the nucleus of an atom. And due to difference in mass, it is applied as energy. So this nuclear binding energy is given by EB equal to delta M C square, where EB is nuclear binding energy, del M is mass defect. As there is difference in mass, so there is energy associated with this. This is known as nuclear binding energy. It is only due to difference in mass of nucleons and rest mass of nucleus. Nuclear binding energy is measure how well a nuclei is held together, right? Hope it's clear to all of you. After that, next important topic is nuclear force. What is the nuclear force? The force acting inside the nucleus or acting between the nucleons is called nuclear force. Inside the nucleus, what is present? Proton and neutron. So the force inside the nucleus or acting between these nucleons is called nuclear force. As both are of same nature, so this is very strongest force. So first important point is nuclear forces are the strongest force in nature. Second, it is very short range attractive force. Third one, it is non-central, non-conservative force. Very, very important property. Fourth one, it is neither gravitational nor electrostatic. It means it do not obey inverse square law. Obey inverse square law. Because both this is gravitational force, electrostatic force obey inverse square law. Electrostatic force is what? K Q1 Q2 by R square, and the gravitational force is what? G M1 M2 by R square. So both obey inverse square law, but it does not obey inverse square law. So it is neither gravitational nor electrostatic force, and it is independent of charge independent. So these are different properties of nuclear force. Then next topic is nuclear energy. What is this nuclear energy? You know, nuclear energy is energy that holds together the nuclei of atoms. Nuclei of atoms means both protons and neutrons. Both are present inside the nucleus of an atom. So energy required to hold these together inside the nucleus of an atom, that is called nuclear energy. And nuclear energy can be obtained in two ways. First one is breaking of heavy nucleus into two lighter nuclei, and this process is known as nuclear fission. Another process is combining two lighter nuclei to form a heavy nucleus, and this process is a nuclear fusion. In both these processes, nuclear fission and nuclear fusion, large amount of energy is released. That is called nuclear energy. So nuclear energy is becoming a possible solution for the energy crisis in the world, and this electrical energy can be harnessed from this nuclear energy. So after this, I am going to discuss about these two types of reactions, nuclear fission and nuclear fusion, with the help of which nuclear energy can be obtained. So what is this nuclear fission? Nuclear fission is process of splitting of a heavy nucleus into two or more lighter nuclei. This process is called nuclear fission. For example, suppose uranium-92-235. This is a target nuclei over which a slow moving neutron strikes. It produces 92-236. This is unstable. So it broken down into, it splits into barium 56-141, krypton 90-36-92, and 3 neutrons released with large amount of energy released in this process. This uranium-92-235 is target nuclei. This is barium, this is krypton and neutron. This reaction is known as nuclear fission reaction, as here heavier nucleus is broken down into two lighter nucleus by release of large amount of energy released in this process. You can write in this way: uranium-235 plus neutron 01, it produces barium, krypton and 3 neutron plus large amount of energy Q is released. This is slow moving neutron N01. It strikes with uranium-235, it produces barium, then krypton and 3 neutron is released in this process. This is nuclear fission. This nuclear fission, there are two types of nuclear fission reaction, that is nuclear chain reaction. What is the nuclear chain reaction? If the particle starting the nuclear fission reaction, we discussed in the last slide, is produced as a product and further take in nuclear fission reaction. Here in nuclear fission, 3 neutrons released. Again these 3 neutrons further taking part in nuclear reaction, fission reaction. Then a chain of fission reaction is started, which is called nuclear chain reaction, right? If suppose in the first one, uranium-92-235, it strikes with neutron 01, it produces barium 56-141 plus krypton 36-92 plus 3 neutron is released in this process. Again these 3 neutron again take part in nuclear fission reaction. So what happened? Again 1 neutron produces barium, krypton and neutron. Again second neutron also produces barium, krypton and 3 neutron, and third neutron also strikes with uranium-92, produces barium, krypton. In this way chain reaction goes on. This is called nuclear chain reaction. These are of two types. One is controlled nuclear chain reaction, another is uncontrolled chain reaction. First I am going to discuss uncontrolled chain reaction. The reaction is uncontrolled and rapid. Here the reaction keeps increasing and becomes huge, right? Energy produced in this, release in this process is of the order of mega electron volt. So application of this uncontrolled nuclear chain reaction, atom bomb, hydrogen bomb, nuclear bomb, all is working is based on uncontrolled nuclear chain reaction. Here number of neutrons striking next target by number of neutrons emitted is always greater than equal to 1. So this is used to produce atom bomb, hydrogen bomb, nuclear bomb, right? Now control chain reaction. In control chain reaction, the reaction is controlled and steady. For example, you know a fusion reaction is what? Uranium-92 plus neutron strikes, it produces unstable nuclei, then barium, krypton and 3 neutron is produced. By any method, if 2 neutrons are removed and only 1 neutron is allowed to hit the next target. So in this case, reaction goes in controlled way. Energy released is less as compared to energy released in nuclear fission reaction. And here one most important application is nuclear reactor, where electricity can be produced. No need to discuss in detail, only you must know nuclear reactor is working based on control chain reaction, and this is used to produce electricity. Here number of neutrons exceeds next target, however number of neutrons emitted is less than equal to 1. So this is nuclear reactor. How this neutron strikes with target nuclear, it produces barium, krypton and 3 neutrons are generated. By any method 2 neutrons are absorbed, only 1 neutron is allowed to strike with the next again target nuclear. So in this way this nuclear reactor works. So this nuclear reactor is used for producing electricity. It is an arrangement to generate electricity which makes use of nuclear fission reaction. After this, last important topic is what do you mean by nuclear fusion reaction. Both nuclear fission and fusion reaction are used to produce nuclear energy. So in this nuclear fusion reaction, it is a process of combining 2 lighter nuclei to form 1 heavy nucleus. For example, suppose 3 deuteron nuclei H12 fuse together, 3 deuteron H12 plus H12 plus H12. Both these 3 fuse together to form helium nucleus He24, and large amount of energy is released on order of 21.6 mega electron volt energy is released in this process. So in this process large amount of energy is released. Nuclear fusion takes place only at very high temperature. It is very important condition, and very high pressure. Hydrogen bomb is based on nuclear fusion reaction. Also the source of sun's energy is the nuclear fusion taking place inside the sun. Nuclear fusion reaction takes place, and that's why this is source of sun's energy. The source of sun's energy, hydrogen bomb, is based on nuclear fusion reaction. So these are about nuclear fission and nuclear fusion reaction, and this is the last topic of this chapter. This chapter is very small, so hope it's clear to all of you. Okay students, with this I am going to end my class. If you like this, don't forget to share and subscribe my channel. Okay students, till then keep revising and stay tuned with this channel. Thank you.